Hello, and welcome to another lesson in Encouraging Engineering. Today, we're going to learn how to manipulate an RGB LED using a potentiometer. This will be somewhat similar to our previous lesson using a normal LED and a button, but now we'll be exploring some more advanced components and coding concepts. So let's get started with the components we'll be using. For this project, you'll need one Arduino, one breadboard, 8 wires, 3 220 ohm resistors, one RGB LED, and one potentiometer. Before we start, let's talk about how the RGB and potentiometer work. While it looks similar to a normal LED, an RGB is special in that it can turn a variety of colors. It does this by manipulating the values of its 3 pins, which control the red, green, and blue colors in the bulb as shown in the picture here. The longest pin in the middle left area here is the ground pin, which we need to connect to the ground of our Arduino. The potentiometer is a twistable knob used to manipulate values. It's important to note that there's a variety of different potentiometers to use, each with their own pin setups. This project will be using a 3-pin potentiometer and has the pins set up as shown on screen. There's a chance you're using a potentiometer with a different setup, so try to look up the component you're using and make sure you set up the pins correctly if it looks different than the one I use here. Luckily, the code in this project should work for any potentiometer you use. Now that you know your components, copy the circuit set up in this image. Pause the video if you need more time. Before we start coding, we need to understand the difference between digital and analog. Take a look at the pin slots and their labels on your Arduino. Next to the power section, there should be an area called Analog In with numbered pins starting with A. These pin slots are dedicated to components using analog data. In electronics, digital measures if there is voltage or not. We represent this in code by saying a component is high if it's on and voltage is detected, or low if it's off and no voltage is detected. In contrast, analog represents a specific voltage value, usually showing it through numeric data. If we coded an LED with analog data, we wouldn't put whether it's on or off. Instead, we would be more specific on the brightness level and say something like, I want the LED to have a brightness of 220 pWm. Here, we're going to use an analog data to read numerical data from the potentiometer and set the specific values on the RGB. As we turn it, the Arduino will read specific numerical values, and we will use these values in the code to determine what color the RGB will turn. Remember, digital is simple on and off data, and analog is complex and specific number data. As always, let's start by making our variables. To control our RGB, we need to control the values of the red, green, and blue pins to change its color. So, we need to make 3 variables relating to each pin. Make sure the variable number corresponds with the Arduino pin. Under the RGB variables, we need 2 variables to use the potentiometer. First, we'll make a variable called pot pin, which will designate where the potentiometer is connected in the Arduino. Next, we will make the variable pot value, which will measure and store the voltage value of the potentiometer as we twist it. We'll set it at 0 for now, but we'll be doing more with it throughout the project. This value is important since it will determine the RGB color. Next, we'll move on to the setup function. Remember, we use the pin mode function to show the Arduino how our components will work. For this project, the RGB pins depend on the potentiometer, so we'll put the RG variables as outputs and the potentiometer as the input. In the loop function, we're going to set up the pot value variable to read the potentiometer values. To do this, we need to use a new function called analog read. Similar to digital read, analog read is used to read voltage values for a component, except this function reads the analog values instead of digital. This means that instead of reading if the potentiometer receives voltage or not, we will read exactly how much voltage is passing through. By setting the pot value variable equal to the voltage value read from the potentiometer, pot value will represent the data we need from the component. Now, let's use our new variable to determine the RGB colors. Our goal is to change the RGB values depending on the potentiometer value, which means we want different outcomes based on different conditions. That means we need an if-else statement. A potentiometer can read values between 0 and 1023 volts. so we'll set our conditions around these numbers. For our first condition, we'll set the color for when the potentiometer reads a value less than 341. For the outcome, we need to set the brightness of each RGB pin to manipulate the color. To change their values, we'll use another new function called analog write. Like analog read, this function works with analog values, but instead of reading the analog values, now we can change them. In the parentheses, make sure to put the pin you want to change and the value you want to set it as. Do so for all 3 pins. This example here should turn the RGB red since we're only making the red pin bright, but I encourage you to be creative and explore with different values. As a side note, you can make the RGB pin values any number between 0 and 255. For the second condition, we'll have the RGB turn green when the potentiometer value is between 341 and 682. First, we'll put else if instead of if. While we could put else like in our previous lesson, else if allows us to set a more specific condition, so it works better for this project. In the parentheses, we need to clarify that pot pin should read greater than 341 and less than 682 for this condition to be met. Notice that we put 2 and symbols between these conditions, which indicates that both must be true for this outcome to run. This is called a Boolean operator, and there are a few others you can use in your programming. I won't discuss them much in this video, but I left a link in the description if you're interested in learning more. Under the condition, we'll use analog write to change the RGB pins again. If you're following the example on screen, the RGB should turn green when the conditions above are met. For the final condition, the RGB should turn blue when the potentiometer value is greater than 682. Again, we'll use else if to set the condition. Underneath, change the RGB pins one last time. Once you've finished, you can plug in the Arduino to test your project. If something doesn't work correctly, there are a few ways to troubleshoot the problem. First, double check that the circuit setup and programming are right. Make sure that the RGB and potentiometer are wired correctly, and check that the variables are set to the right Arduino pins. Luckily, there's a useful trick for checking variables in Arduino, and that's by using the IDE's serial monitor. To access the serial monitor, open the Arduino IDE and click the magnifying glass in the top right corner. Next, go back to the setup function and put serial.begin 9000. This will configure the serial monitor for your project. In the loop function, type serial.println and put the variable you want to test in parentheses. Let's say you chose pot pin. When you start the program again, the serial monitor should start showing numbers that will increase or decrease as you turn the potentiometer. The variable is correct if the number decreases when it turns left and increases when it turns right. If something else happens, then you need to check the code or wiring of the potentiometer. You can do the same for the RGB variables to check them too. This method is great if you want to be specific about what you're checking. If you're interested in learning more, some extension ideas with these components could be keeping the RGB the same color but increasing the brightness as you turn, and making the RGB turn colors other than red, green, or blue. Also, there are some links in the description to helpful websites if you need something clarified. Anyway, that's all for this video. I hope you learned something new today, and I encourage you to explore more on your own. Thanks!